Hi, my name is Gar, and now I'm going to be talking about matched t-test and pool t-test. The reason why I decided to pull these two together is because I used to confuse them a lot. I thought I just kind of thought that they were the same and stuff, but they're not, and they're used in very specific situations. So I decided to put these two together in one video just to explain the differences. So the matched t-test is a procedure when we basically test the same group twice. So for example, if we do a test on a group of students, then we let them study for a week, and then we test them again and see if their grades have gone up and that sort of thing. And I mostly compare it to the one sample t-test. The formula is almost completely the same, but I will go over it in a second. And the pooled t-test is more like the two sample t-test. So the formulas are kind of different. So let's start with the matched t-test, which is basically the same as our one sample t-test, sample t, which had the formula x bar minus the null divided by standard deviation divided by n. Right? Well, now we have one group, and we tested them twice. So instead of comparing it with the null, we are gonna go x1 minus x2. So the mean of the first testing and the mean of the second testing divided by s divided by n, because these two don't change. They still have the same standard deviation and they still have the same n because it's just the same group twice. Why don't we use the null? The same reason why we don't use the null in our two sample t-test, because our hypothesis, the null hypothesis, is basically the mean of the first one and the mean of the second one is the same and therefore is 0. Subtracting 0 from something leads to nothing, so we just ignore it and we keep it together. We also see it written as difference minus mu0 divided by s divided by n. It is literally the same thing. This is the same because x difference is x1 minus x2, and the null is always just 0. So you can write it however you want, but you get to the same point. So let's go over an example. Let's say we have a group of people and we made them do a test first, and we found these results. So they had a mean of 30 minutes, and there was a standard deviation of 10, and we tested 40 people. And then we gave them all a few shots of vodka, and they had to do it again, and now they're slower. So now it took them 40 minutes total. Well, let's look at our null hypothesis first. Our null hypothesis would be the difference between the two is 0 between the two groups. So before alcohol and after alcohol, the difference is 0, versus our alternative that the difference isn't 0, or that mu1 is smaller than mu2, whatever. It boils down to the same thing. Then let's actually plug it into our formula. So it's 30 minus 40 divided by 10 divided by the square root of 40. That gives us minus 6.324. And if we then look at our... Also, the degrees of freedom are still the same. It's just n minus 1, so that is 39. Look at our formula. We can see that 39 isn't an option, so we round down. We go to 30, and then we look it up, and we see that it's way ahead over there. And if that is the case, we look at this sucker over here. Seeing that, we can assume that P is smaller than 0.0005. Thus, if we compare it to our usual alpha level of 0.05, P is smaller than alpha, therefore we reject the null. That's it. That's the only difference. The only thing different in the matched t-test is that instead of the null hypothesis, you just use your second x, your second mean. All right, that is the significance test for the matched t-test. Now let's try the confidence level, because that is just as easy. It is just x1 minus x2 plus minus, and then we have to look at our degrees of freedom again. That is 40 minus 1 is 39. Seeing as we don't have 39 on this thing, we round it down to 30, which means that we look at 95% at 30 is 2.042. 2.042 times 10 divided by the square root of 40. If we plug that in, we find 3.228, which means that we now have 30 minus 40 minus 3.228, and 30 minus 4, that's a interesting 4. 40 plus 3.228 is minus 13.228 and 6.7, minus 6.772. So the interval is between minus 13.228 and minus 6.772. That is everything for the matched t-test. Basically, it is literally just the one sample t procedure, but do it with your two x's instead of your mu, because your mu is just going to be 0. Well then, now let's look at the pooled t-test. Pooled t-test. I compared that one to the two sample t procedure, because the formula is practically the same. I'll quickly look at my notes. There we go. So the formula for the pooled t procedure has this whole thing of s squared 1 divided by n1 plus s squared 2 divided by n2, right? This is the only thing we're going to be changing, aka we're going to be changing the s's. What you do is that, why do we do this pooled t-test? Basically, it's when we have two samples, but we assume them to have the same standard deviation in the population. So how do we get our pooled standard deviation, right? We get a formula for that. Or at least we need to memorize a formula for that. And it's a very annoying formula. I wish I could make it easier, but this is just something that you have to memorize. So the formula is n1 minus 1 times s squared plus n2 minus 1 s squared divided by n1 plus n2 minus 2. And that is your pooled standard deviation, and then you use that in here. That's it. So instead of having two separate standard deviations, you basically use this one twice. So let's actually put this in practice. Let's say we have two groups. these are the statistics for group 1. So a mean of 30, a standard deviation of 10, and an n of 25. And then we have a secondary group. So, for example, this is our, I don't know, psychology year 1 students. And then these are our psychology year 2 students. We assume that they have the same standard deviation in the true population, even though the individual samples are different. So we're going to pool them. There we go. Then we start pooling. Get that stupid formula back out. So 25 minus 1 times the square root of 10 plus 29 minus 1 times the square root, the square root of 14 divided by 25 plus 29 minus 2. And that is your pooled standard deviation. Then let me quickly check so I don't miss a step or anything. Nope. Pretty sure I got that. Alright. So we now have our pooled standard deviation. Perfect. Let's put it into the formula. So it's basically the same formula as the 2-sample t procedure, which is x1 minus x2 divided by pooled standard deviation squared divided by n1 plus pooled standard deviation squared divided by n2. Let's plug that in. 30 minus 39 divided by the square root of, and we calculated this one, it is 12.268. So it is 12.468 squared divided by 25 plus 12.468 squared divided by 39 is minus 2.645-ish. Now, how do we find our degrees of freedom? In our 2-sample t procedure, non-pooled, we just grab the smallest one. But because it's pooled, we actually add them together. So it is n1 plus n2 minus 2. And in this case, that is 25 plus 29 minus 1, minus 2 is 51. Seeing as 51 isn't an option on this table, we go to 50 because we round down. We kind of just look around and we find that our value ends up at p between 0.01 and 0.005. Seeing as that is our p score, assuming that our alpha level is still 0.05, it means that our p is, that is an r, our p is smaller than than our alpha, thus we reject the null. Perfect. Then let's do it again, but this time with the confidence interval. And we're going to keep this up because we calculate the pooled standard deviation the exact same way. So if we had our 2-sample t procedure non-pooled, which would be this times S2 1 N1 plus S2 2 N2. The only difference here is that we're going to be changing those up So now we are going to have to look at our t. How do we get our t? Degrees of freedom. N1 plus N2 minus 2 is 51. We don't have 51, so we're going to round down to 50. If we're going to continue looking at the 95%, like a 95% confidence interval, we see that it is 2.009. So x1 minus x2 plus minus 2.009 times, let's move this a little bit, there, which would be 12.468 squared divided by 25 plus 12.468 squared divided by 29, which gives us an interval of about 6.836. Then let's look at 30 minus 39 divided minus 6.836 and 30 plus 39. How did I get 29? 25. Yeah, I was freaking out for no reason. Never mind. 39 plus 6.836 is, let's see, minus 15.836 and minus 2.164. So our interval would be between 15.386 and minus 2.164. And that's the only difference between the pooled and the non-pooled standard deviation. Inference and stuff, and the procedure. The only difference is that instead of having individual standard deviations, you just pull them together. It is a good way to check is that your pooled standard deviation is always between those two scores. If you get one that is smaller or bigger than than either of them, you probably did a calculation error somewhere. So if I, for example, got a 9 out of this, that's impossible because it has to be somewhere in between these two. And when it comes to in the exam, try to look for keywords such as assumed the same or equal or anything that would hint at you having to pool these standard deviations together and that it is one cohesive whole. But yeah, that is everything I have for the matched and the pooled t-test. I hope this was helpful.